Hello, this is Mr. Huber. In this lesson, we're going to learn about graphing quadratic equations in the form y equals ax squared plus bx plus c. So we're going to have all three terms of that quadratic trinomial. Recall a quadratic equation has a U-shaped graph called a parabola. The lowest or highest point of the parabola is the vertex. And the line that goes down through the middle of the U shape, through the middle of the parabola, dividing it evenly on both sides, is called the axis of symmetry. Those are going to be two key things to start with. The first thing we're going to find to be able to graph a parabola, a quadratic equation, is the axis of symmetry. And from the axis of symmetry, we'll be able to determine the vertex, and from there, the rest of the graph. So everything starts with the axis of symmetry, which can be found x equals negative b over 2a. It's a vertical line, so it's an x equals linear equation. Okay, so we're going to find x equals negative b over 2a. So it's going to be x equals some value, and it's going to be a vertical line through that x value that's going to be right down the middle of our parabola. Okay? This x value will also always be the x-coordinate of the vertex. That's why I said we're going to start with the axis of symmetry, and from there we'll be able to find the vertex. And then from there, we're going to plug in other values to get a table of values and draw our graph. Okay, but first let's start with just how do I find an axis of symmetry? How do I find a vertex? Then we'll see how to draw a whole graph from there. So in these first two problems, we're just going to find the axis of symmetry and the vertex. So the axis of symmetry, right, is x equals negative b over 2a. So x equals, the b value here is negative 2. So negative 2 over 2 times my a value is 1. So 2 times 1. So that's 2 over 2, which is 1. And now to find the y value that will go with that x value for the vertex, we're going to plug that 1 back into the equation. So we're going to take the 1 and we're going to plug it back into the equation. We're going to get y equals 1 squared minus 2 times 1 minus 3. That's 1 minus 2 minus 3. So that's negative 4. So my vertex is going to be the point 1 comma negative 4. My axis of symmetry would be x equals 1, what I found here, right? Remember, this is an x equals. So the axis of symmetry is x equals 1, and the vertex is the point 1 comma negative 4. Remember, the axis of symmetry, that x value will always be the x value of the vertex. That's why we can plug that value in, find the y value that goes with it, and that gives us a point that will be the lowest or highest point on our graph. All right, and number 2, again, we're going to start with x equals negative b over 2a. So x equals negative 12 over 2 times 2. That's negative 12 over 4, which is negative 3. So the axis of symmetry is x equals negative 3. Okay. Now to find the vertex, I'm going to take negative 3 and plug it into my equation. So I have 2 times negative 3 squared plus 12 times negative 3 minus 7. That's 2 times 9, which is 18, minus 36 minus 7. So it's negative 18 minus 7, which gives me negative 25. And so my vertex would be point negative 3 comma negative 25. Right? So you start with x equals negative b over 2a. That's how we're going to start everything we do, finding an axis of symmetry, finding a vertex, then drawing a whole graph from there. Even when we find minimum and maximum values, it's going to always start with x equals negative b over 2a. So after we get that axis of symmetry and vertex, now we want to make a table of values. We want to have 2 points on either side of that axis of symmetry. So when we didn't have a b value, we just used negative 2, negative 1, 0, 1, and 2 because our axis of symmetry was always at x equals 0. It's not always going to be there. My axis of symmetry is not always right down this axis. So I need to find out, is the axis of symmetry over here, is it over here? And I want to get a couple points on either side of wherever that might be. So we're going to have 5 total points, the vertex and 2 points on either side. All right, so now let's see what that looks like in problem number 3 here. We want to graph this. We're going to start with x equals negative b over 2a. So x equals negative 12 over 2 times 3 is 6. That's negative 2. And then I'm going to plug that in to get my y value. So y equals 3 times negative 2 squared plus 12 times negative 2 plus 9. And you could put that all into the calculator in one step if you want. Whatever you want to do to follow order of operations, do your calculations here, and you get y equals negative 3. So now I've got my vertex with an x value of -2 and a y value of -3. And I can make a table of values now. Okay, my axis of symmetry would be a vertical line that goes right down here through the middle of my graph. My parabola is going to be something that opens a U shape on either side of that with a vertex, as we just found, at -2, -3. So that's the point right here. And so now I want to plug in points on both sides of that. I want to see what happens on both sides of my U, whichever way it's opening. I should know here with an A value that's positive. It's going to open up. So I want points on both sides. I want to plug in -3 and -4, and then -1 and 0. Right? So find the middle and plug in 2 points on either side of the middle. So when I make my table of values, okay, -2 is going to be in the middle. And then I'm going to have -3, -4, -1, and 0. We already know when we plug in -2, we're going to get -3. Okay, when I plug in -1 into there, I'll get a 0. When I plug in 0, I'll get 9. So you can do those calculations and make sure that you're plugging those in and getting those proper points as well. And so now I can graph those other points. So -3, 0, -1, 0, 0, 9, and -4, 9. And I will have a parabola that I can draw a smooth curve through those points. And there's my graph for y equals 3x squared plus 12x plus 9. All right, let's continue graphing some quadratic equations. Here we have y equals -x squared minus 6x minus 4. We're going to start with x equals -b, so -6 is 6, over 2 times -1 is -2. So it's going to be -3. Always start with -b over 2a, always. And now we plug that in to our equation, and we're going to get y equals negative and -3 squared minus 6 times -3 minus 4. And that's going to come out to 5. So now I've got my vertex is at -3, 5. Right, so I'd have an axis of symmetry at -3. There'd be some vertical line going down here. I'd have a vertex at -3, 5, -3, 5. Okay, and from there I can find my table of values. So x and y values, and my x values are going to have -3 in the middle. I'm going to have -4, -5, -2, -1. I know when I plug in a -3, I'm going to get 5. When I plug in -2 and I'll get 4. When I plug in -1, I'll get 1. Again, you can do those calculations. You should be able to plug these in. If you're not getting those values, let's figure out where we're making some calculation errors in terms of getting our x and y values to draw our graph. And now we're going to plot those points. So I'm going to graph those points. Okay, so I'm going to start -5, 1. All right, then I've got -4, 4. Then my vertex I already graphed, -2, 4 right there, and -1, 1 right here. And then I'm going to draw my parabola, smooth U-shaped curve going through those points, and there's my graph. Okay, my axis of symmetry is x equals -3, right? My vertex was the point right here, -3, 5, right? That's my vertex. My axis of symmetry, x equals -3, and I got my graph. And it should open down, right? So when you graph this, make sure it makes sense. When you're getting your points here, if you're not getting the same values on either side, that's an issue. When you draw your graph, it isn't a U-shaped parabola, right? This should open down because of the -a value. Make sure those things are matching up with what you'd expect to see for each particular graph. And let's try another one here. Again, you should try this one. Do this one, and then see how you are at graphing it. So we're going to start with x equals -b over 2a. X equals -6 over 2 times 3, which is 6, so x equals 1. And my vertex, I'm going to plug a 1 in for y, so I get 3 times 1 squared, so that's 3 minus 6 plus 2, right? So that's going to be -1. So my vertex would be at the point 1, -1. So I've got an axis of symmetry here of 1. I got the vertex at 1, -1. That'd be the point right there. It's going to open up from here. We should expect that. And now we can make a table of values. So I'm going to have x and y. Right? 1 is going to be my middle x value. Remember, whatever value you get here for this in the middle, this is my middle x value. Middle x value, I want 2 points on either side of the middle. So 2 points on either side of that. So I'm going to have 0 and -1, 2 and 3. Right? And so I already know that when I plug in 1, right, I got -1, and now I'm going to plug in, let's say 0. 0 is pretty nice and easy to plug in. If I plug in a 0, 0 minus 0 plus 2, so I'm going to get a 2 right there. And then if I plug in a -1, you should get 11. When you plug a 2 in, and let's just make sure, right, we could say, hey, I don't want to assume I'm going to get a 2. Let's plug in a 2. So 3 times 2 squared, which is 4. So 3 times 4 is 12, minus 6 times 2, which is 12. So 12 minus 12 is 0, plus 2 would be 2. So I'm going to get a 2 for both these, which I should. So that's a 2, and then I'm going to get an 11 right there. And now I can graph these points. So I've already got the 1 comma negative 1. I got negative 1 comma 11. So let's move this down a little bit so we can fit that here. It's a little bit off of our graph. So negative 1 comma 11. 0 comma 2 right here. I've got 2 comma 2 and 3 comma 11. And I'm going to draw my parabola through those points. And there I've got my graph. My axis of symmetry is x equals 1. My vertex, the point right here, is the point 1 comma negative 1. So we've got our axis of symmetry, x equals negative b over 2a. Plug that value in to get the y value of the vertex. Right? This x value will always be the x value of the vertex. Plugging it in gives us the y value of the vertex. That gives us the middle of our parabola, the middle for our table of values. Then we plug in a couple points on either side, so we have other points to graph. 5 total. Draw your smooth U-shaped parabola curve through them. All right, before we look at more parabolas and graphs of quadratic equations and one more aspect of those, deck of playing cards. You might be familiar with the 4 suits in a deck of playing cards. If not, right, these are the 4 suits that you would see on your cards. Okay, where do they come from? Why do we use those symbols on a deck of playing cards? Well, it comes from the French. Right? They settled on and came up with that current deck that we commonly use now with 52 cards, 13 cards in each of the 4 suits: spades, hearts, diamonds, and clubs. That's these right here: spades, hearts, diamonds, and clubs. And you can see they represented something in society back when they came up with this deck of playing cards. The spades were for the nobility, the hearts for clergy, big-hearted clergy, that's nice. The diamonds representing the merchants, right, for bartering and trading and value of goods. And then the clubs were for the working class peasants. All right, so that's where those come from and why they originated and why the French determined those 4 suits to kind of represent their societal classes and their deck of playing cards. One more aspect for these parabolas of quadratic graphs is identifying a minimum and maximum value. It's really not new. We've seen on a graph, right, the low point and the high point. That's the vertex of the graph. Okay, we want to recognize that when the graph opens up, when this a value is positive, that's going to be a minimum, the lowest point, and it's the lowest y value. So when we talk about minimum and maximum values, we are talking about y values. Okay, and so we can calculate that by finding the y value of the vertex. How do we do that? Well, we're going to start with x equals negative b over 2a, and then plug that in to get that y value. All right, so in this first example here, number 6, we're going to calculate x equals negative b over 2a, so that's negative 8 over 2 times negative 2, which is negative 4. That's 2. And I can plug a 2 in now to find the y value. So that's going to be negative 2 times 2 squared plus 8 times 2 minus 4. So 2 squared is 4 times negative 2 is negative 8 plus 16 minus 4. So that's going to be 8 minus 4, which is 4. So the y value is, in this case, it opens down because we have a negative a value. It's a maximum. It would be the point right here. So it's a max value of y equals 4. Maximum value of y equals 4. In this next example, we're going to start again with x equals negative b over 2a. So negative 5, it's a positive 5 over 2 times 1 is 2. So we have 5 over 2, or 2.5. Doesn't matter to me which one you use. Okay, I would say if you're going to put in a calculator, most of you are probably going to want to use the 2.5, which is fine. So when you calculate that and you put in 2.5 squared minus 5 times 2.5 minus 4, you're going to get negative 10.25. And this is a graph opening up because the a value is a positive 1. So it's going to be a minimum value of y equals negative 10.25. Okay? So minimum and maximum values, those are the y values of the vertex. How do we find that? We start with x equals negative b over 2a. We've seen that throughout everything we've done. Start there. That gives you the axis of symmetry, gives you the x value of the vertex that you can plug in and find the y value. When we want to get a table of values, we find a couple points on either side of that, and then we can draw that parabola, that smooth curve. Right, keep in mind some of those key features where the axis of symmetry, the vertex, notice if it's opening up or opening down. You can start with x equals negative b over 2a.